for their containers. That's such an easy one, right? Like, oh, man, I need storage. Right? So it's all about storage. So I'm the moderator today. I have, I'm not sure about protocol about this, but I have some smart people here that are going to talk about storage today, and I'll try to keep them in check. That's my role. So why don't you guys introduce yourself? Why don't you start out? Tell us who you are, what you do, and what your company's doing that's interesting with storage and containers.
Yeah, I'm Paul Searles, Executive Director at Portworx. Portworx helps folks run stateful containers at scale, running, schedulers like Redis.
Hi, my name is Brian Bulkowski. I'm the CTO and founder of a company called Aerospike. We're a database company. As part of the clustered, high-performance, highly available NoSQL category, we do a lot of work with virtualized environments and helping people get through the microservices challenge. And the question always in those environments and projects is, where do you put your data once you've gone down the virtualized and containerized rabbit hole? So I have a few customer stories and hopefully some insights in how that all plays out.
Nice. Hello, my name is Igor Lebedev. I am CTO of SONM. SONM is a distributed fog computing platform. It provides cloud services of a kind, and it's based on the computers from all over around the planet. The computers that were previously used for crypto mining, and now they contribute their power to something useful in practice. So for us, the storage challenge is one of the biggest challenges because the environment is untrusted in some degree, and if the execution is somewhat understandable, the storage problem is one of the biggest. So this would be an interesting talk.
Excellent. And my name is Campbell. I have a little startup I call Wisdom. It's wisdom.sh, and I'm into providing proxy services for APIs using cryptocurrency payments, microtransactions. And I've worked in the log space before, and I worked for a search company as a consultant, and that's how I got here today. So I guess I'll start with you, Paul. It's like, what are the biggest challenges that?
Can I make a request about the sound? We're getting a lot of potential feedback back here. It's really,
Yeah, I think we're just in front of it a little bit.
well, if it's bad for us, it's bad for them.
Is that a little bit better?
Is that a little better?
Hear me?
Can you still hear us?
Yeah, we can talk loud in small enough rooms. Yeah. So, like, what are you seeing your customers today, Paul? Like, the biggest challenges that they're seeing with their containerized storage?
Yeah, so when people run, usually people start off by running stateless containers, right? Running that at scale, and then they mature and start trying to run more inside one platform. And stateful containers is that next step. And I think the challenges for a lot of folks is everyone realizes that they have storage in the data center, so they try to leverage existing assets, and they think that running a volume driver to something that's purpose-built for VMware will be good enough. And anything you get working in a lab, and what people find is that in day 2 operations, things get really hard.
Well, I mean, when you take it into production, right, it starts getting, like, the use cases start getting harder, and reliability, right?
That's right.
Yeah.
So what I end up seeing with containerized environments is I think there's no accident that Redis is the #1 download from the container site, right? Because what happens is the journey you just said, and then everyone goes, they freak out, and they go, well, therefore I need a cache. And then they reach for a RAM-based cache because RAM doesn't involve storage, and what they reach for tends to be Redis. Redis being a great RAM-based system, but caches have a lot of problems. We've learned over the last 2 decades how to deal with caches, and caches are a reasonable solution to things, but essentially you always have inconsistency, right? So once you have 2 copies, you have an inconsistency. What I believe, and that's what our company believes, is that it's better to have a super fast database that doesn't need a cache. Now when you do that, the question is, where do you put your data? Because if you just set up Aerospike with a persistent volume, those volumes tend to be remote and thus tend to be slow regardless of how fast the database is, right? So if you put your PV over Ceph, it's, no database can then be any faster than Ceph is. Ceph's a great system for bulk storage, one of my favorites. So based on this, one of the patterns that I see is you can use the persistent volume in what we call a shadow device configuration. And so I end up recommending that a lot, and it's very similar to how you would configure an Amazon. So in Amazon, let's say you use Flash, which means you can get all this performance. Flash in let's say an Amazon i3 instance is still ephemeral, right? It goes away, it's not storage. It's just like RAM, only cheaper and slower. Therefore, we had to build a system whereby you had a slow device that is only written to and never read from, but still maintains all consistency.
What kind of use cases are you talking about primarily that you're seeing with, like, in challenges in like increasing performance? You're talking about the cache, I mean, those things increase performance, but then you want to have reliable storage, almost immutable storage, if you will. Like, so what are the use cases helping define what? Can you talk to that a little bit?
Yeah, absolutely. So the interesting case, I find there are two cases, and we were having this discussion a little just before this, about whether you're still in the relational model or not, right? And that's the biggest fork that occurs when you're starting to consider storage and database technology for any project, containerized or not. Once you're in the relational world, to my perspective, you're already slow. On the other hand, the database is doing more work, so you've got faster development time. So some things are faster, some things are slower.
Yeah.
There's no free lunch. You move to a key value paradigm, you can get scale, you can get performance, but you probably just made your developers do more work. And so there's
it's a trade-off based on the use case.
Huge trade-off, and this is part of the NoSQL. This is part of the NoSQL world, right? NoSQL comes to you and says, denormalize. And well, everyone from 40 years ago dealing with really slow relational databases knows how to denormalize and knows that it's the key to speed. I mean, that's how we all did. Or you put a cache, you use complex queries and put a cache in front of it.
Yeah.
So in some sense, there's nothing new under the sun. And us NoSQL guys have basically built a great mousetrap for a denormalized schema. But you still have to make that choice. Are you going to go the relational model, have relational systems, etc.? I think what's interesting about containers is they often go with microservices.
Right.
Microservices is a lot about denormalization, right? So if you think about the Facebook architecture, one of their microservices is get me my friends.
Yeah.
There's no relational link that friend still exists, didn't close their account. You have to go to another service to ask. But boy, does that scale, right? So microservice architectures have this. It's not a necessity, but a flavor of denormalization anyway, and tend to get you to higher performance. So for that reason, I tend to see people going to a denormalized NoSQL system, and then the question is, how do I do that in containers in an effective way?
Right.
So it's often user lists, recent user behavior, transactions, the bank account balance, things like that.
Right. I never thought about it exactly like that, but you're absolutely right. That's the thing that microservices give us. Igor, what are you seeing in your particular market? And you guys are doing some interesting, like, you're like...
Fog computing.
Yeah, fog computing with perhaps cryptocurrencies, blockchains?
With blockchain internally, but we don't say this is the most essential part. It's just one of the components that we use because it gives us some flexibility in terms of reaching consensus. Because our system is completely decentralized, it's unmanaged. So the only way how we can achieve this unmanaged state and decentralized state is that we use blockchain and particularly the smart contracts. But I don't promote at this topic some cryptocurrency or whatever. So I would like to catch the topic that was stopped. Again, the SQL and NoSQL databases, because where it started from, people started development using files as databases. Then they thought this is too complex to develop. Let's make SQL databases. And it reached to a state where we have not only SQL standard, but we have TSQL, we have PLSQL. And basically the approach was to do everything on the database, including the application server. And you have only external forms. But then it starts failing to scale because it has a vertical scaling. And then we have the backwards trend, and it started to offload the application server from the database. We have free component architecture. Then we go to NoSQL solutions, and then we go to microservices, and we are starting to bring the complexity back to the code, because complexity will live somewhere at least. Because if we need something to be working good, it must be simple. If we want the databases to scale well, it must be simple, so we must put the complexity out. So we have the key value. Or we have even simpler things like just object storage with hash storage, without even lookups. So, but that scales very well.
What would you say that the use cases are, I mean, they're sort of defining type of complexity,
Okay, okay. We provide a platform for people to offload their computational tasks to the fog. This gives you two basic benefits. This is a geo-distributed because you cannot put data center at each service provider because we have computers everywhere. And the second point is the price, because this is a consumer-grade hardware, and no data center provider or cloud provider can achieve the prices based on the enterprise hardware with enterprise support compared to the consumer grade. This is just times cheaper. But we get back to the software developers and we say some people have software and applications that may offload their data there. But is that convenient enough for them to do that? And currently this is not really convenient because this is a degree of optimization for costs. They may optimize costs and trade costs for complexity a little bit. Because to make your application work in the fog, you have to rewrite it. You have to at least go away from monolithic approach and to use microservices. You have to start using key value. You have to trade off your consistency in the database. And we see this trend happening. People are already doing this because currently at this moment, some time ago where there were no any applications, people wanted to develop applications fast and easily, and SQL databases helped to achieve that because they took the complexity on them. But now we want software to be fastly deployed. We need to be easily managed and easily scaled because this world is too fast. Yeah. So the older approach, they don't work anymore. And people are slowly rewriting this, but we have still a lot of legacy for the 20 years. But I think we will have at least 5 years until we will have a really serious rewrite in the software architecture. So we have more microservices, more key values, and that kind of things. And for that cases, our system is beneficial because people will not have to rewrite particularly for SONM. If they have microservices and key values, that is fine. We can provide a key value storage for SONM. Basically, we have a problem of providing SQL-grade database because it must be managed. And it must be managed and it must be placed on untrusted hardware. This is complex. But at least if we trade off for key value storage, there are existing project attempts to make key value storage in a managed mode in a distributed environment. For example, Aerospike is one of the attempts. We just can consider them for this particular environment.
Right.
Well, so this is about the complexity.
Thank you for that. I mean, one way that I think about sort of the edge or fog computing stuff is to consider that when you, I mean, most people know about Moore's law, right, where you have this sort of increasing compute speed. But there's also another law that is sort of, or a rate of acceleration for network. So you have, in compute's going up like this, network kind of goes up like this. It doesn't get as fast as compute does. So you sort of see things naturally sort of percolating toward the edge. But then I was asking Paul about business models earlier and how they were changing. And one of the things that I've sort of noted is as we see things sort of getting pushed out to the edge, the data sort of has to live at the edge and the compute sort of falls to it, which is what you're talking about, right? Is that the business models have to change. And so are we looking at a resurgence of MSP models maybe in this market? I'll let you guys take a whack at that. Does that make sense? I mean, are we all going to turn into MSPs here, or are we going to be able to still provide services?
Microsoft Service Partner?
Oh, yeah, managed service provider. But, you know, managing. So to give you context, I consult for LucidWorks, and we're a search company, and search is one of those weird things. It's not like you can say search is a market, because you can do search for the web, and you can do search for documents, and you can do search for, you know, I don't know, website search or something like that, right? Or even log files, which is the market I came from, right? Each one of those is just a completely different market, but you're applying search to it. But storage is also one of those things that spans markets. So do you feel like you might be doing more MSP stuff or less MSP stuff in the market that you're playing in? I guess that's the question for each of you. Take a whack at that, Paul. Hope I didn't make that too complicated.
Yeah, I mean, I think what people are really looking for is some consistency and data portability. I think that those are key characteristics when they're thinking about how they're going to run stateful containers. I think that folks are trying to find ways of having a multi-tenant environment that can handle all types of use cases and run on top of, have an abstraction layer that can run on any type of environment, VMware, OpenStack, bare metal, and or pick your favorite cloud. And not have to change the tool set as they make different decisions of where things run, I think is really important. And as they make those decisions, have the flexibility to be portable with their data. Just like containers can run anywhere, can the infrastructure live and breathe and follow that container as it moves? And I think that's really the trend that people are really are searching for.
So like consistency in the underlying infrastructure, no matter where it goes.
Consistency also from the user perspective. So the user runs something in Kubernetes, call it a storage class, and that runs exactly the same way no matter where it runs physically.
Yeah.
The user, it's very similar to like say Gmail. Gmail, you don't really care where your email is being actually placed. Like when we use Gmail, we're not wondering how Google is storing our data. We're wondering how Google is storing our email. The user wants the same experience through Kubernetes. They don't care where it runs. They want it to run, and they want to have the flexibility to build characteristics into how they run that workload. And if the underlying infrastructure ever changes, you're saying move to the edge, that is abstracted from the user.
Interesting. So how do you guys help? Like if you abstract it away, so then you're sort of managing the idea of where it could be run.
So Portworx is not only the volume driver, but also the storage layer, right? And you know, our colleagues here are talking a lot about performance and optimization for, say, a particular workload. What we try to do is try to provide one single tool set for many different workloads. I think the key here is that we're able to hyper-converge and fully integrate into the Kubernetes ecosystem. I think that's really important.
Yeah, I mean, when you talk about convergence, it's really talking about being able to have that anywhere, the storage anywhere from the customer standpoint. Like they don't have to think about that problem anymore. It's abstracted away for them.
It's abstracted away from them, and then they're just running, not ever having to run through Portworx, but actually running through their favorite flavor of Kubernetes.
Yeah.
So I think that the most interesting is not honestly containers. I think it's orchestration. Right, so containers are a wonderful thing. I got nothing against containers. I have all the love for containers because as a high performance database, I know what the tax of a true VM is on every packet, on every storage read, and on every memory access. It's high. And the VM guys have done more and more work to make it better, you know, power to them. But what the container guys say was, okay, if you're willing to give up a little security, we all know that that's sort of the interesting point about containers, to your point about untrusted environments, then you can get back a lot of performance. Okay, now great. As a guy deploying or a person, an architect trying to figure out what tech to use, I've got virtual machines, I've got containers, they have different trade-offs in price performance. The battle starts moving to what's my orchestration mechanism? Am I in Pivotal? Who's launching these things? Am I in Kubernetes? Et cetera, et cetera. So the sophistication of those models, especially regarding locality of compute and storage, becomes really the most interesting area, I think, right now in terms of this whole landscape. I think there's still jobs for data architects. And I think that knowing where your data is, you simply can't expect millisecond response time because there's this funny thing called the speed of light. And if I could bend it, I would. I try every day. But a system will perform differently regarding where it is. And if you say, well, I'm going to make sure that a key value lookup is the same no matter where the data is placed, okay, you have to assume that's on the other side of the world. and then everyone has to architect for that worst case. And I bristle against that. I think we should be able to make the optimizations as architects to say, I want some of my data this close, and I want some of my data this far, and et cetera, et cetera. Someone's got to make that choice. Just because of the speed of light. If it wasn't for the speed of light, I think we would have a lot more options. So I really look to orchestration mechanisms to allow me to make those trade-offs, and frankly, I haven't yet seen the sophistication in any of them that really allows me to say, well, this PV is here, this storage mechanism is here, this is what the latency constraints are, et cetera, and propose those in the interface. And I keep complaining about that kind of thing to my friends at Kubernetes, Mesos, and Pivotal, and all those guys.
That's really interesting. And, you know, what popped into my mind was AI. Like just having an AI figure it all out, right? Like just to have
well, and so us as humans, we're the dumb form of AI, and we have a certain price performance and a certain energy consumption, and other later forms of AI may have different price performance considerations. So whether you're using meatware or AI, that's all the same thing.
Same thing.
Yeah, but yeah.
That's perfect. Igor, what do you think?
What I think, just keeping the free speech about based on the question, but you mentioned fog computing, edge computing. You know, it all started being simple. It all started from a monolithic applications, and then it started growing with abstractions. And the proper use of abstractions helps you to reduce the complexity in a given single piece of anything. So the complexity is growing at this moment. We already have microservices, so the complexity is already split by everywhere. Now we have databases without consistency. So, and I think the next steps would be the convergence of the fog computing, and because the network is a bottleneck, because you cannot transfer everything to the cloud just because the IoT devices and everything grows in 3 dimensions, but the line to the data center can only grow in 2 dimensions. Anyway, you cannot travel everything there, and particularly because of the speed of the light, not to mention this. So it will be somehow particularly being solved on the edge and then in the fog. But this again leads us to a more complex development, more complex applications, because you have, for example, let's consider, for example, Facebook or whatever. We have a complex information system. We have a complex different level of storages. So some parts of the data must be consistent, some not. For example, keeping pictures doesn't require really consistency. If you lose it, okay, you lose it, no problem. You should not lose the payment data, and you should keep it private. But this not relates to the videos, for example. So I mean that the architecture of the software is going different and complex, and more level of abstractions appear. And some of them prove themselves after years, and then we have this as a standard. So back to us, we try to make system agnostic of the different storage engines. We just would like to provide it as a usable solutions for some cases. And at this moment, we see that, of course, storage is not our strongest point, but we can provide cheap and effective execution. And there are indeed a lot of tasks that require that. For example, rendering. You don't really need a database to run a render effectively. You don't really need a huge database or like sophisticated database to do machine learning. You have a task, you just input the data, then you get back the weights of the model, and you are fine. Or if you use already trained model, you just set up the model, and then you have task execution. You give the data to the input, give the result, take the results back. So for that cases, we perfectly fit. And if you talk about the storage, there are different solutions for storages. That allows you, for example, blocks, object storage. You can effectively keep the data in an untrusted environment. But if you would like to work with that data, that would be a little bit more complex. So you may store it, but if you would like to work, this is another story. We can provide, for example,
because it might be stored off somewhere.
Yeah.
And you need to work on it.
Still, we may be a system for a stateless execution and use the storage of external, or like managed somewhere outside or internally. So there are different options. Okay, this is what I think about all this.
Thank you, I appreciate that. It's interesting. Does anybody have any questions? We're about, we have about 10 minutes left, I think. I think we're about 30 minutes up to the hour. Anybody have any thoughts about, yeah. I'm just asking if you have some seed questions for us that we could like riff on. Yeah, go ahead.
But the question is, with the container and the bus system, is this an anti-pattern? Some people say if you're going to use containers, if the stateful containers where you need the persistence, then don't do containers, just do the bare metal or the VMs. Like the Cassandra or any databases that you're running, because then you have to make sure if the container restarts, it has to go to that volume, or if it affects on anything like that. So that's one of the challenges we run into.
So let me take a crack at that. This is where I'm going to go back and preach about orchestration mechanisms, right? So a sophisticated orchestration mechanism would allow you to mix and match to a greater extent, right? So if you want to follow the procedure where I have a bare metal database, which has its own benefits, and I want to take some particular set of applications and run it against this one, or I want to then put a cache in the middle for optimization, it's really, I would hope, the sophistication of the, or not do bare metal, do it a different way, right? Your orchestration mechanism, I would hope, is the one that's allowing you to say, put this part here, put this part here, look at the path lengths, et cetera, et cetera. I almost think of it as the next coming of DBAs, or storage managers or network managers all come together if you want to try to gain more performance than the lowest common denominator system. So those choices are all valid, and when I walk into a scenario like that, I try to help them. Maybe the software, whatever you call it, Bluemix these days. Bluemix has a great program for bare metal where you can drop shit into a rack that's co-located with your other chips. Amazon, right? So that's connected. So you have to try it. And I find that one way fits all, which is why I keep going back to the orchestration mechanism. There's going to be a place for each path.
Are we going to do a whole bunch of different orchestration systems?
I mean, this is your point, right? So if maybe we can pick one and then all get behind it, because sort of like a message bus, right? We're all lining up behind Kafka, and if we all line up behind Kafka and do our Kafka connectors, the world gets better. If I have to support 10 message buses as Aerospike, oh my God, each one has its own consistency guarantees, blah, blah, blah. I'm happy to try to give that crown jewels to that one component in the message bus, thus let 1,000 flowers bloom at the data layer. Same thing with orchestration mechanisms. I don't want to have present this key component to one company that's then going to throttle us for the rest of our lives, which often happens when it's a private entity. On the other hand, it's going to make our lives so much easier if we can all work to improve one or two key infrastructure components. But they better be good, right?
Right. Reliable. Well, I mean, I guess depending on the use case. I mean, I sort of want an AI that says, this data is really important to you.
You're out of a job, you realize that.
Yeah, that's true.
Okay.
But I mean,
social problem.
I mean, like, maybe it could just come to me and go, hey, I have a problem. I can't figure this out, and I was wondering what you thought about it. And then it goes off and takes care of it. Igor, you were going to say?
Yeah, I wanted to add that perhaps the execution and the storage, they just require different approaches at this moment. So what we know from the orchestration at this moment, it perfectly fits the execution if it's stateless. But just the current state of the software development, which partly uses SQL, partly not using, this is really mixed. So this heavily requires a little bit different approach than we have in typical orchestration, because it's typically managed separately from the execution orchestration. So, and by the time we'll go on, and by the time we will reduce the complexity in the database, use more key values, less SQL, only for key parts, then perhaps we can combine it all together again. If the management of the data would be as simple as just moving it around or just restarting it, would be fine. But at this moment, it's just not that easy. So perhaps not a good idea to mess it up.
One thing that sort of springs to mind is I've been teaching myself how to use TensorFlow. TensorFlow is like a machine learning framework from Google, and so one of the things that you can do is download a data set that's already been trained, and so instead of training it yourself, you can, with images, you actually just take the payload. And so when I think about data, I think about like the type of data. I think, well, that's a neural network. And the guy at Google said, well, sometimes we actually prune that thing So you can just prune it, and so you're able to actually move data out of it, and it can still do things like figure out it's a dog in the picture. But then, and I'm gonna bring up cryptocurrencies again, because I'm into that, but like cryptocurrencies, I feel like blockchain provides us, I'm not into the whole ICO thing or tokens or any of that stuff, I'm just into the type of data that the blockchain. Like they want you to sort of abstract all of that away and figure out how they have a particular use case that they're shooting for, within your sort of abstracting away from, so they don't have to think about it. And the reason why you can't do stuff like that, can we replicate all these storage people? If we've got AI coming along, isn't AI going to need storage? Or our jobs secure that? I mean, what do you think? Like, what are your customers telling you about like things that they're using the storage for? I'd like to get back to touch on the use cases just briefly again. Like, what are they doing with it?
So one comment is data architects are definitely very, very important. I was talking just from a user experience they want to have. But on the underneath the hood, where data architects are obviously very important. I think when running on things like bare metal, and I talked about multi-tenancy, people don't, with these orchestrators, the orchestrators will have a very hard time if you have a point solution for every use case, right? And so having kind of a single abstraction layer where things can run consistently without you saying, I'm going to run Cassandra a certain way, I'm going to run something else a certain way, and have all these different point solutions, is really going to make a lot of complexity when trying to run these very advanced orchestrators.
I mean, so I've been doing containers for a long time. I was in OpenStack. So somebody said something to me about operators.
Oh, okay.
Right? Like, so operators to me are like these tasks that I have to do, right? To the network or to the data that I have that's there, right? I'm going to operate on the data. I'm going to manage it. Maybe it's migrating and things like that. I see the complexity increasing with container technologies, and then I want to be able to do something easily myself, so it still has to be approachable to the individual. I mean, it seems like a lot of these solutions just sort of are born out of the need for a given individual to be able to do something meaningful with the data. I mean, that's how you sort of start out as a developer with the technology. As you go, I have this use case, and here's this technology to do this, and then can I do this? So, do you see your maybe where you start talking about like, what are your customers? What is their experience like? Using. What are they looking for out of their storage solutions?
I would like first to add about some words about the blockchain-based project, because we have something that we call traditional software world, traditional enterprise, where we have the whole evolution we discussed in the previous questions, the evolutions about storage and the execution, and now the whole new world emerged. It's just called with one word blockchain, but internally it has a lot of projects. And the blockchain is even not the most essential part, because the most essential part is the consensus algorithm and the way to achieve consensus. Because blockchain, there are different solutions. There are some projects without the blockchain based on for example, graph, or there are three kinds of blockchain. But what is interesting in them is that they, out of the box, since the whole beginning of the Bitcoin and all of the projects, they have solved some numbers of problems that are completely solved. They completely solved the problem of trust and completely solved the problem of replication and the hardware going down, because they are absolutely replicated. You cannot imagine some bad environment, bad computing environment, where they can't operate. So that kind of project, they can operate virtually everywhere. Like on any bad PC, if 90% computers goes down, they will not even notice this.
Like IPFS.
Yeah.
Interplanetary file system.
Not particularly with IPFS, because if 90% of IPFS go down, I think they don't have replication factor of 10, so I think data would be lost. But in the case, for example, for Ethereum, which is essentially a single-threaded computer all over the world, it will not notice it at all. But when they will implement, but the problem they have, they're completely not ready for production because of performance. So this is just another group of developers and people going from the other side to some central point. We will sometime in the future we'll meet the traditional software world and the blockchain community. So they just made different key solutions, and now they're trying to solve performance, and we are in the traditional world trying to solve some different things.
Yeah, I mean, we've been tackling performance because it makes money, right? Performance
Yeah.
makes money, right? And it almost seems like that's a very clear-cut thing on one side. In the enterprise market, you've got the need for performance in a given market. It's the innovator's dilemma, right? You're always cranking, an incumbent is always cranking up on improving performance for customers, which adds value, you make more money. On the other side, you've got the cryptocurrency peeps who are working on high decentralization, but then the reliability is not the same, and the performance is not the same. And privacy,
Yeah.
For individuals.
So if I can talk about performance for a minute, because Aerospike does focus a lot on performance, which in some ways is, it's interesting, as we were saying before, in a containerized environment. So the driver that I see in enterprises for performance is a richer customer experience or of some sort in order to drive better user experience, right? So the internet companies, the Googles, Amazons, Facebooks of the world, have all driven these wonderfully rich user experiences. And when I go to my bank and I say, what is in my account, that's a solved problem, right? North America transactions run even on the fastest of days at 10 to 15,000 a second. It's no big deal. And they do want to have, even within banks, things like if you call a support person, it is immediately reflected in your mobile app if they make a change. That's actually kind of a hard data problem and do it in real time as opposed to batch overnight. They'd like to get there. But if I go to Google, I see in Google Wallet immediately, well, okay, they don't have any service people you can call. They solved it a different way. But I immediately see things, right? So we've got this world where the traditional enterprises solved a bunch of hard problems in data without containers, without internet technologies. The internet guys have made a richer user experience, and now we all expect it. So now the foot is shifted back, the problem is shifted back to the enterprise. How do I get that kind of user experience? Because what if Amazon opens a bank, right? Oh my gosh, I'm in trouble. So that's the route that when people come to Aerospike and they're saying, I'm in an enterprise and I need performance, and I say, why? And they go, because the internet, because there's people in the internet internet companies who have internal databases that are fast, reliable, that they're not open source, not published, not available through cloud APIs, and I have to go fight against those guys, and I'm girding up from that. So those are all the discussions I have. How do I make a better user experience? Part of that is development time, right? Part of that is, therefore you get into these discussions about SQL, NoSQL, denormalization, et cetera. Part of it is how to orchestrate for scale when it takes off. A richer user experience is more data and more compute. Okay, now we're in the question about, am I in the fog? Am I co-locating my data? Do I scale problems with that, et cetera, et cetera. It's all very interesting.
Just to add one more point to this topic about the top companies like Google and Amazon, they can perform things that cannot really be achieved by other companies not on their place, because just to achieve the mentioned user experience of the replication of data at the real time, what do? They buy dark fibers. They buy communication lines that are limited and not achieved by anyone. So they do an unimaginable business with internet service provider, with tier one. They buy direct fiber lines between the data centers, and you cannot just do that because the number of fiber lines is just limited, and they are already sold to these cases. So basically, they have advantages cannot be achieved just with the common actions. But I think just if we had an unlimited number of time, perhaps if we had 100 years since the moment, if everything will freeze and if we just sit down by our computers, we could do a software solution that would somehow magically replicate everything in correct order with correct queues and everything. But it will just take us a lot of time. So, but I think as the time goes on, companies and people not accepting this dominance of the companies, they will develop some solutions. But
if they're still alive.
Yeah, if they're still alive and if they don't agree. Because, for example, the whole blockchain thing is that they just don't trust the existing solutions. They will people using Bitcoins, they are ready to wait 2 days for their transactions to arrive, just because they can, because they don't trust anyone. So if they can wait 2 days, they will tolerate even better experience. So,
Right. Speaking of time, we're I think at time, but we'll take maybe a question or two here in a second. But I wanted to comment on, it's interesting talking about. I mean, I don't idly talk about blockchain technologies, and I always refer to it as blockchain. But I think about it as when you're talking about consensus.
Consensus and trust.
Consensus and trust with data, like with your data storage. Sometimes you have a use case that requires a large amount of consensus and trust. Sometimes you have use cases that doesn't matter. If you're playing a video game, who cares? You can score that high score, right?
Are you
it might
kidding?
not matter. It might not matter. Well, maybe if it's Donkey
What
Kong. I mean, I'm talking about, casual
if I'm
playing
playing a
game.
network game that I've invested days of my life into, and I transfer a pony to my daughter, and
Yes.
she doesn't get my pony, I mean,
Yes.
you're in trouble, right? Where's
Yeah.
my pony?
But-
Oh, it got lost in the database.
Yeah, but you got a pony that you need stored for sure, but I have like some game that I just play.
It's in a
and
game, and
that's
it's an
gone,
in-game
right?
pony.
Yeah, I get that.
Yeah,
Yeah, I mean,
right.
I think it's when you
It-
call
it-
it-
I'm sorry, I've dealt with a lot of game guys.
it's just a
and they
question,
are strict on
you know,
I
consistency.
clearly hit a
It
button.
is just it is a question of what's important. If the user experience is the most important thing, then we can compete with that.
Yeah.
But if the important thing is that you want trust, if you want to have the future, then you have to make some trade-offs in the user experience to support the ideas and the development that will be in the future be a little bit compared to what we have now.
Yeah.
Because if everyone uses the experience criteria.
I have a question up here. I think we can take like 2 questions.
So I want to ask about a specific problem that a lot of companies have, I think. Let's say there's a company that's operating in a data center, and they're on bare metal, and they want to move to virtualized environment and also containers, or containers, so moving away from bare metal. If they have distributed databases or data-related services, specifically say Cassandra or Kafka, as an example. These services are actually written and designed such that they assume or they prescribe direct attached storage. So if you ask the Cassandra guys or Kafka, they'll say, hey, don't go over the network, right? Because the server itself, the compute part of that service expects the storage to be directly attached. Otherwise, you go over the network and then you've lost a key part of the design, which is now you don't have isolated failures. Like if a disk goes down, you're safe in Kafka and Cassandra, but if you're using a SAN, for example, then you're doomed if the SAN fails. So, do you think that we're doomed to using these types of services that are very popular, Kafka, Cassandra, these types of things on bare metal, or what would you prescribe in a virtualized environment or even with containers? If I wanted to
Well, the first thing I'm going to prescribe is that you switch from Cassandra to Aerospike. Well, since this is the database question, let me try to answer briefly. Some of the points you just made are very specific to Cassandra's implementation, and they don't even exist with Kafka. I was mentioning this in my opening remarks. We don't prescribe at Aerospike locally attached storage. If you read our website, you would believe that, but we have this shadow drive. The shadow drive says that your persistent store can actually be further away, your long-term persistent store, like EBS, right? EBS is low performance, but you can use even a local flash storage or just RAM, and that's okay, you'll still get your performance. So the fact that Cassandra doesn't support that, well, I don't know, go bug the Cassandra guys for that. So I think that there are a wide variety of technical solutions. We've implemented some of them that get you out of a lot of these problems. And still maintain consistency, right? Because if the data layer does it, as opposed to simply having a cache in front of you, which is the other way around this problem, right? Use a relational store, put a closed cache in, you've got consistency violations. And Cassandra is already an AP system, right? It doesn't support consistency. So I don't know, there's some complexity there. But my first thought is, of course, get rid of Cassandra. But I'm biased, so maybe someone else should answer.
And just to continue this thread, after you switch to Aerospike, you may then move your infrastructure partly to the SONM. and then reduce your costs 5 times.
Absolutely.
Paul, you were going to thank
So
you.
I would just say that you're not doomed. We actually have customers Portworx that run in production at scale, running those specific use cases on bare metal. We solve those problems by providing an abstraction layer that runs across all the bare metal machines. And Cassandra and Kafka think they're talking about local drive. We do not shard the volume. We always place a hyper-converged virtual volume of Portworx to that Cassandra or Kafka microservice.
Which sounds a lot like the shadow drive that I was talking about. So there's a variety of technologies here that can help, that are a way out.
But perhaps it will require a little bit of rewriting the software.
I'm sorry, could you repeat that?
I mean that it will perhaps require to rewrite software in some degree.
Yeah, how it's operating. I know, operating. Well, that's it. We're out of time. We're over by 7 minutes. Guys, I appreciate it. Paul, Brian, Igor, thank you. It was a pleasure. Thank you for your time. Very much. Put a hand on it. Thank you all.
If anyone has specific questions.